This video is on electric force and electric field strength. Question number 1. What is charge? Is it a scalar or vector? What are its units and fundamental units? Charge is a property of matter. Its units are coulombs or an ampere second. So remember this, coulombs is not a fundamental unit, but both amperes and seconds are. Question 2. What is the difference between an electrical conductor and an electrical insulator? In an electrical conductor, electrons can move easily in an object, like metals and seawater. In an electric insulator, electrons cannot move easily in an object, like wood or rubber or glass. So this should remind you of a thermal insulator and a thermal conductor. Question 3. Two charged objects with the same charge will repel each other, while two charged objects with the opposite charge will attract each other. Question 4. State the charge in coulombs of each particle. A neutron has 0 charge of 0 coulombs. A proton has a charge of 1.6 times 10 to the minus 19 coulombs. And an electron has a charge of minus 1.6 times 10 to the minus 19 coulombs. So this is important. The electron is not missing any charge, even though you see that negative sign. Question 5. There is a metal sphere which has a net positive charge. Is there any negative charge in it? The answer is yes. Where does the extra positive charge go? It goes to the surface of the object. Question 6. State the law of conservation of charge. The total electric charge in an isolated system is constant, or the total amount of electric charge in the universe is constant. Question 7. A pith ball has a surplus of 4.2 times 10 to the 15 electrons. What would be the net charge on this ball in coulombs? So we want to go from the units of electrons to the units of coulombs. So we started with electrons here. Then we multiplied it by the number 1. 1.6 times 10 to the minus 19 coulombs per electron. If an electron over electron cancels, we just get coulombs in the numerator. Question 8. A pith ball has a shortage of 1.85 times 10 to the 17 electrons. What is the net charge on this ball in coulombs? So we're going to go from electrons to coulombs. So we were given this. We're going to multiply by the number 1. So that's what's in parentheses. The numerator is the same as the denominator. And we end up getting something in coulombs. So number 7, there's a mistake. This should be a minus sign. Okay? Negative charge. Question 9. How many electrons will be contained in a net charge of 1250 microcoulombs? So we have 1.250 times 10 to the minus 6 coulombs. We multiply it by the number 1, and we get an answer. So for question 7 and 8, we go from electrons to coulombs. Now in question 9, we're going to go from coulombs to electrons. Question 10. A pith ball which has a residual charge of minus 38 microcoulombs is brought into contact with a second identical pith ball, which is initially neutral, allowing charge to flow between them. These two balls are then separated. What will be the final residual charge on each pith ball? Well, if they're identical pith ball, that means they have the same surface area. And since each electron wants to go as far away from each other as possible, each pith ball is going to have a charge of minus 18 microcoulombs. That's a net charge. Part B, how many extra electrons will be present on each ball after they have been separated? So we're going to go from coulombs to electrons. Question 11, a pith ball which has a residual charge of 54 microcoulombs is brought into contact with a second identical pith ball which has an initial residual charge of minus 38 microcoulombs. What would be the final residual charge on each pith ball after they have been separated? Well, it's an identical pith ball, so they have the same surface area. And this extra charge wants to be as far away from each other as possible. So what's 54 minus 38? It's 16. And 16 divided by 2 is 8. So each pith ball will have a charge of 8 microcoulombs. Since the excess or extra positive charge wants to move as far away from each other as possible. Question 12. A pith ball which has a residual charge of 66 microcoulombs is brought into contact with a second pith ball which has an initial residual charge of minus 33 microcoulombs and which has twice the surface area of the first pith ball. What would be the final residual charge on each pith ball after they have been separated? Okay. So one pith ball has twice the surface area of the other. That means that one pith ball is going to get twice as much excess charge. Because remember, the extra charge wants to be as far away from each other as possible. So 66 minus 33 is plus 33. 33 times 2/3 is 22. And 33 times 1/3 is 11. So one pith ball is going to get plus 22 microcoulombs. And the other pith ball is going to get plus 11 microcoulombs. Question 13. Define and give the units of each variable in Coulomb's law. F is equal to kqq over r squared. So this is the electric force between two charged objects. Okay. So K is a constant, 1 over 4 pi epsilon sub 0 or epsilon naught. Q1 and Q2 are the net charges on two objects. And R is the distance between Q1 and Q2, like the distance from the center. And E sub 0 is called epsilon naught or E sub 0. We need a minimum of two objects to use Coulomb's law. And we cannot consider induced charges. What's an induced charge? I'll let you know later, hopefully. Question 14, define relative permittivity E sub r. So take a look at this equation. If we are not in a vacuum, then Coulomb's law becomes 1 over 4 pi epsilon sub r. This should be E sub r. Where E sub r is a it should be 1 over 4 pi epsilon. Where epsilon sub r is E over E sub 0. So E sub r is greater than or equal to 1 since epsilon is greater than epsilon naught or epsilon sub 0. So the relative permittivity is also called the dielectric constant. And remember, this equation looks similar to what we learned about law of refraction in Snell's law. And here are some common dielectric constants for dielectric materials. Question 15. What would be the magnitude of the electrostatic force between two identical pith balls, each of which has a residual charge of 24 microcoulombs, which are 15 centimeters apart? So just use the equation kqq over r squared. Question 16. What will be the magnitude of the electrostatic force between two pith balls 23 centimeters apart if the residual charge on the first pith ball is minus 31 microcoulombs, while the residual charge on the second pith ball is 12 microcoulombs. So you could see what was done here. Just use KQQ over R squared, just like in question 15. Question 17. What would be the electrostatic force between a proton and an electron when they are placed 0.5 angstroms apart? So 1 angstrom is 1 times 10 to the minus 10 meters. Question 18. What would be the magnitude of the electrostatic force between 2 protons in the nucleus of an atom, which are approximately 3 times 10 to the minus 15 meters apart? Question 19. Use Coulomb's law to determine the electric force on a point charge. Part A. Q1 and Q2 are fixed. Find the force on Q3. So Q1 and Q2 are not moving. What's going to happen to Q3? Well, Q1 is positive. Q3 is positive. So Q1 is going to push Q3 to the right. Q2 is negative, Q3 is positive. So Q2 is going to pull Q3 to the left. So remember, circle the object, label the forces, put an X and Y axis, and use Newton's second law. So I circled Q3. I labeled the forces. Q1 pushes Q3 to the right, Q2 pulls Q3 to the left. And I drew an axis. I said positive X is to the right. X equals 0 is where Q3 is. Now I'm going to use Newton's second law to determine the net force. So there's only one dimension, a line. So we're only going to use it once. Sigma F sub X equals MA. And I have this equation. We have two forces. You see, Q1 pushes Q3 to the right. That's why there's a positive sign. Q2 pulls Q3 to the left, that's why there's a negative sign. And now we get this. And now we just plug in everything and we get this as an answer. Now the negative sign means that the force is to the left. Notice here, over here, what I highlighted. I did not write down the sign for charge because it's not needed. So I didn't write down negative charge. Now let's look at the original question here. Q1 and Q3 are fixed. Find the force on Q2. So Q1 and Q3 are not moving. Q1 is positive, Q2 is negative. So Q1 is going to pull Q2 to the left. Q3 is positive, Q2 is negative. So Q3 pulls Q2 to the right. So we get this. So let's find the net force on Q2. Circle the object, label the forces, draw an X and Y axis, use Newton's second law of motion. So that's exactly what I did. Okay. So sigma F sub X is equal to minus force of Q1 on Q2 plus force of Q3 on Q2. There's a minus sign here because Q1 pulls Q2 to the left. There's a plus sign here because Q3 pulls Q2 to the right. So we get this. And then we get this by substitution, or by factoring. And putting everything in, we get this as our solution. So there's a positive sign, which means the positive x-axis. That means to the right. It's being pulled to the right, or pushed to the right. Question 20. Use Coulomb's law to calculate the electric force on a point charge. The point charges Q1, Q2, and Q3 are fixed. Find the force on Q4. So Q1 and Q4 are both positive. So Q1 pushes Q4 southeast. Q2 is negative, Q4 is positive. So Q2 pulls Q4 up. Q3 is negative, Q4 is positive. So Q3 pulls Q4 to the left. So this is in 2 dimensions. So circle the object, label the forces, put an X and Y axis, and use Newton's second law for the x-axis and the y-axis. So you could see Q1 pushes Q4 southeast, Q2 pulls Q4 north, and Q3 pulls Q4 west. Okay. So right now I have to calculate this angle in green, theta. I need to calculate the angle the force Q1 makes on Q4. This should be a Q4. Okay. So this is 20 meters, this is 14 meters, so tangent of theta is 20 over 14. So this is 55 degrees. So this red triangle and this green theta is going to be equal to 55 degrees. So if we say the positive x-axis is 0 degrees and we're going to go counterclockwise, this is going to be 270 degrees plus 55. So that's 325 degrees. Okay. So step 4, calculate the total force on the horizontal axis. So here we're just going to use cosines. And we end up getting this value for our force on the x-axis. Then we're going to have to calculate the total force on the vertical axis. You could see the difference between the x-axis and the y-axis is that the x-axis uses cosines. The y-axis uses sines. And this is what we get for f sub y. So you have f sub x and f sub y. It makes a right triangle. This is the magnitude. And now we have to find the direction. So f sub x is positive. F sub y is positive. So we're going to have to get a theta. And that's going to be 61.6 degrees. So this image is not correct because, once again, f sub x is positive, so draw an arrow going to the right. F sub y is positive, draw an arrow going up. And we're going to find the magnitude here, which is the hypotenuse. And what's theta? It's this. Question 21, use Coulomb's law to calculate the electric force on a point charge. So this looks like a isosceles triangle, okay? Q1 is plus 2 coulombs. Q2 and Q3 are both minus 3 coulombs. So point charges Q2 and Q3 are fixed, meaning they don't move. Find the force on Q1. So Q2 is going to pull Q1 southwest, since they're opposite charge. And Q3 is going to pull Q1 southeast, since they have the same charge. So, remember, circle the object like I did in purple, label the forces like I did in blue, put an X and Y axis like I did in pink, and then use the equation. So right now I want to find the angle of this red arc. It's 20.49 degrees. And then what's the angle of the orange arc? It's negative 20.49 degrees. And mathematically, remember this, sine of minus theta is sine of theta. No, sorry, there should be a negative. There should be a negative sign here. Sine of negative theta is negative sine of theta, and cosine of negative theta is cosine of theta. So this first one is incorrect. I apologize. So sigma f sub x is equal to f sub q2 on q1 plus f sub q3 on q1 in the x-axis. And you can see the x-axis here is straight down. So this is the magnitude going down. What's sigma f sub y? It's 0, and that should make sense because q3 pulls q1 to the left, q3 pulls q1 to the right with the same magnitude on the y direction. So this is just the computer going funny. I apologize. Question 22. Explain the meaning of charge being quantized. So quantized means charge comes in multiple integers of 1.6 times 10 to the minus 19 coulombs. Question 23. Give an example of how two objects can transfer electric charge by friction. Okay. Rub a glass rod with a cloth. Electrostatic induction. Bring a positively charged object near to a neutral charge metal. The positively charged object will attract the negative charge and repel the positive charge. The two objects do not touch each other. So that's electrostatic induction. Part C, by contact. Two conductors, at least one with a net charge, touch each other. And finally, grounding or earthing. A charged object has a wire attached to it. The wire leads to the ground. The excess charge goes to the ground. Question 24. Define electric field strength. E is equal to F over Q equals K over Q over R squared. What is the minimum number of objects required to use the equation for electric field strength? Electric field strength is electric force per unit charge, has units of newtons over coulombs. And these are the fundamental units. And we need a minimum of one object to use the electric field strength equation. So imagine we have a positive charged object here. You see that circle? People would ask, what's the electric field strength at point 1? What's the electric field strength at point 2? So we could compare these two equations, electric field strength and gravitational field strength. They both look very similar. There's a constant K and G. There's a 1 over R squared. They look similar mathematically. This is something you need to memorize. Draw a graph of electric field versus distance of a positively charged object of a positively charged solid conducting sphere. So, if this is conducting, then the electric field inside is 0. Then outside is goes down as 1 over R squared. Why? Because electric field is KQ over R squared. Okay. Question 26. Draw a graph of electric field versus distance of a positively charged solid insulating sphere. So this is insulating. 25 was conducting. So for an insulating sphere, it's going to look like this. You see, inside the sphere, the more outside we go, it goes up linearly, the electric field strength. Then, as we leave the surface of the sphere, it goes down as 1 over R squared. Okay. So, the electric field inside the sphere increases linearly because the extra positive charge is spread throughout the sphere. Okay. And the electric field strength outside the sphere decreases as 1 over R squared because E equals to KQ over R squared. Question 27. What will be the strength of the electric field at a point in space where a 5 microcoulomb charge feels an electric force of 0.0450 newtons. Well, they gave us Q and they gave us F, so we could solve for E. Question 28, a charge of 8.5 microcoulombs is placed in a uniform electric field which has an intensity of 8 times 10 to the 3 newtons over coulombs. What will be the magnitude of the resulting force? Remember, F equals QE. Question 29, a proton is placed in a uniform electric field which has an intensity of 6.5 times 10 to the 5 newtons over coulombs. Part A, what will be the magnitude of the resulting electrostatic force? Remember, F equals QE. Part B, what will be the resulting acceleration of the proton as a result of this field? So A is equal to F over M. So we were given Q and we were given E. So we could solve for F. And F equals ma. So that's how we got this. Question 30. What would be the electric field strength 45 centimeters from a pith ball, which has a residual charge of 5.5 microcoulombs? So we're given R, and we're given Q. And we know K is a constant. Question 31. What will be the electric field strength at distance 2450 angstroms from the nucleus of a helium atom? So a helium atom has a proton and an electron, BAM. So that's why we have this 2. It's 1.6 times 10 to the minus 19 coulombs times 1.6 times 10 to the minus 19 coulombs. Part B, a carbon atom. Remember, a carbon atom has 6 protons. So that's why there's a 6 here. I apologize, helium atom, not hydrogen, it's helium. Helium has 2 protons in its nucleus. Question 32. A small pith ball which has a mass of 0.056 grams and contains a residual charge of 5 microcoulombs is sitting in a vertically oriented electric field as shown below. The force of gravity acting downward on this ball is exactly balanced by the electric field directed upward. Part A, what will be the gravitational force acting on the pith ball? So it says gravitational force, so F equals mg. X downwards. Part B, what will be the magnitude of the electrostatic force acting on the pith ball? Well, it's sitting. That means it's not moving. So F equals ma, A is 0, V is 0. And it tells us force of gravity down is equal to electric force up. So if this force is down, then this force has to be up. And electric field lines always point from positive to negative. So there's positive charge on the bottom, there's negative charge on the top. Part C, what is the magnitude of the electric field that is supporting this ball? F equals QE. Question 33, determine the magnitude and direction of the electric field at point X. So what's the electric field here at point X? Well, we have the charge of A and the charge of B. Let's say the positive X direction is to the right. And point X is the location of a positive test charge. Okay, it's a test charge. So if A is negative and at point X is a positive charge, A is going to pull this positive charge to the left. And if B has a positive charge, and at point X there's a test charge that's positive, B pushes X to the left. So that's why this has this equation here, and there's two minus signs. Because A pulls x to the left, B pushes x to the left. Because x, there's a positive test charge. Question 34, determine the magnitude and direction of the electric field at point x. Okay, so remember, x is going to have a test charge that's positive. Okay, so A is negative. So A pulls x to the left, and B is positive. So B pushes x to the right. So we're going to use this equation here. Once again, A pulls x to the left, and B pushes x to the right. And notice this distance is 0.21 meters, because that's the distance from A to x. Question 35, determine the magnitude and direction of the electric field at point x. Okay, so this is in 2 dimensions now. So now we got to do that x-axis, y-axis thing, okay? So we're going to put a test charge here that's positive at point x. Now, if A is positive, it's going to push x southeast, which we have in red. And if B is negative, it's going to pull this test charge that's positive to the west. So what's this theta here? Okay, that's what we should figure out. We need to find this length from A to x. Using geometry or trigonometry, we're going to find that out. So E sub x is going to be this. You see there's a plus sign on both because this theta will make sine and cosine positive or negative. So this negative sign means that E sub x is to the left. So that means the green electric field strength in the x direction is going to be stronger than the red electric field strength in the horizontal direction. And now we've got E sub y, which is negative, which means that the green only pulls it to the west, but the red pushes it southeast. So the red has a negative direction in the vertical direction. That's why it's negative. Okay. So we're going to find E, and now we could find theta. Question 36, determine the magnitude and direction of the electric field at point x. So Q sub A is negative, Q sub B is positive. So if we put a positive charge at x, Q sub A pulls it down, and then Q sub B is positive, so it pushes x to the left. Okay, so x is the location of a positive test charge. So it's going to look something like this diagram here. So here's E sub x. Here is E sub y. Here is E. And here is theta. So E gives us the magnitude, theta gives us the direction. Question 37, determine the magnitude and direction of the electric field at point x. So Q sub A is negative, Q sub B is negative. So if there's a test charge at point x, Q sub A pulls it down, Q sub B pulls it southeast. So it's going to be like this, okay? So remember this. So E sub x is going to be this. Because I'm saying theta equals 0 is in the east direction, and now we're going counterclockwise. And E sub y is this. And you notice they're both pulling this down. So E sub y should be negative. There should be a negative sign. And this is our solution for E. That's the magnitude. This is the direction. Question 34. Two pith balls, each of which is suspended from the end of a piece of very thin thread, are attached to a common point of suspension. Each pith ball has a mass of 0.130 grams, and each piece of thread is 12 centimeters long. Each of the two pith balls is given a net charge, and as a result, the two pith balls repel one another until the angle between a pith ball and the vertical increases to 16 degrees. So part A, what would be the magnitude of the electrostatic force between these two pith balls? So sigma F sub y is equal to MA equals 0, because A is 0, this isn't moving. So circle the object, label the forces. We have force of tension, force of electric, force of gravity. So this is what force of tension is. And this is sigma F sub y. So this is the first step here. And this is where we solve for force tension. Now what about the x-axis? Well, we have two forces on the x-axis, electric force and tension force. So we could solve for electric force. So remember, circle the object, label the forces, put an x and y axis, and use the equation F equals ma. So part A asks for the magnitude of the electrostatic force. So we'll be able to find that. Part B, determine the magnitude of the charge on each ball if the charge is distributed evenly between the two balls. So first determine the distance between the two balls. So we're going to use some geometry. Now we're going to use Coulomb's law. Okay. And we solve for Q. So they could both be positive charge or they could both be negative charge. Part C, assuming that this charge is negative, how many excess electrons will be found on each ball? So now they're telling us it's a negative charge. So we're going to go from coulombs to electrons.